Hello, my name is Nathan, and today we'll be finding the three reciprocal trigonometric ratios. So in the past, we used three common trigonometric ratios, which is sine, cosine, and tangent. Most people memorize it as SOHCAHTOA. So the first one is sine of theta is equal to opposite side over the hypotenuse. Cosine of theta is equal to the adjacent over the hypotenuse, while tangent theta is equal to the opposite side over the adjacent side. We use these three trigonometric ratios in order to find the missing length, side, or the missing angle in a right triangle. So now introducing the three reciprocal trigonometric ratios. The three reciprocal trigonometric ratio is secant, cotangent, and cosecant. As you can see up here, these are the abbreviation of the three reciprocal trigonometric ratios. The first one is secant. Secant of theta is equal to the hypotenuse over adjacent side, which is also the inverse of cosine, which is 1 over cosine. The second one is cotangent, which is equal to the adjacent over the opposite, which is also the inverse of tangent, written as 1 over tangent. The third one is cosecant, which is the hypotenuse over the opposite side, which is the inverse of sine, which is written as 1 over sine of theta. So now we will apply the three reciprocal trigonometric ratio in the given problems. In problem 1, find the cotangent ratios of angle B. So I know that the cotangent ratio has a relationship with tangent. So first, I found the tangent of B. So tangent is the opposite over adjacent. So angle B, I know that the opposite of angle B is 6. And then the adjacent is 8. So my ratio for tangent is 6 over 8, which I simplified to 3 over 4. I know that there are two different functions for cotangent. So I did the first one, adjacent over opposite. So I know my adjacent 8 and my opposite is 6. So which got me to a ratio of 8 over 6. And I simplified it to 4 over 3. So my cotangent ratio of angle B is 4 over 3. My second function I did was 1 over tangent B, which is also known as inverse tangent. I know my tangent is 6 over 8, which is right here, because I did it in the beginning of the problems. So I got 1 over 6 over 8. I know that I cannot have a fraction in the denominator, so I did the inverse of 6 over 8, which is 8 over 6. When I do the inverse in the bottom, I have to do that the same at the top. So I got 8 over 6 and 8 over 6. My denominator canceled out into 1, which got me 8 over 6 by itself. And I simplified to 4 over 3. And my answer I got for cotangent ratio of angle B is 4 over 3, which is the same answer I got up here. For problem number 2, find the cosecant ratio of angle X. I know that cosecant has a relationship with sine, so first I found sine. Sine of angle X is equal to the opposite over hypotenuse. So I know my opposite side from angle X is 4, and my hypotenuse is 5, which got me 4 over 5. I used the two cosecant functions in this problem because I want to show you that you can get the same answers by using two different functions. So I did the first one, cosecant of x is equal to hypotenuse over opposite. I know my hypotenuse is 5 and my opposite is 4, which got me 5 over 4 as my ratio. So my cosecant ratio of angle x is equal to 5 over 4. I used the other function, which is cosecant of x is equal to inverse of sine, which is written as 1 over sine over x. So sine of x is shown up here because I did it in the beginning of the problem, which got me 1 over 4 over 5. I cannot have a fraction in the denominator, so I did the inverse of it, which is 5 over 4. And whenever I do something at the bottom, I gotta do the same thing at the top. So now I have 5 over 4 because the denominator cancels out into 1, which got me the same answer as I did with the first function for cosecant. So for problem number 3, I had to find the secant ratio of angle P. So I know the secant has a relationship with cosine. So what I did was found the cosine of P, which is adjacent of our hypotenuse. I know my adjacent of angle P is 5 because if I do the opposite of angle P, which is 12, I cannot do that because I'm looking for cosine. So my adjacent is 5, my hypotenuse 13, which got me 5 over 13 as my cosine ratio. But I'm not looking for cosine ratio, so I have to use a secant ratio, which there are two different functions for it. So the first one is secant P is equal to hypotenuse over adjacent. Hypotenuse is 13 because I can see it in this triangle right here. And the adjacent is 5. So which got me 13 over 5 as my secant ratio of angle P. I did the second function of secant, which is 1 over cosine P, which is also known as inverse cosine. I know my cosine is 5 over 13. I did 1 over 5 over 13, but I cannot have a fraction in the denominator, so I had to do the inverse, which is 13 over 5. Whenever I do something at the bottom, I gotta do the same thing at the top, which is 13 over 5. I cancel out the denominator because it becomes 1, which gives me 13 over 5 by itself, which got me to the same answer as my first function. Thank you for watching my presentation.